Welcome to Polymer Science and Engineering at UMass Amherst. I'm Laura Bradley, and I lead the HIT Materials team. Our team studies how to harness interfacial phenomena for the synthesis and assembly of soft materials. Current projects in the group examine the fabrication of functional polymer coatings using chemical vapor deposition, and also the synthesis of advanced colloids with a variety of shapes and compositions using heterogeneous polymerization. An overarching theme of all projects in the group are to examine and understand how the methods that we use to make our materials is directly connected to the structure and composition, which ultimately determines their applications as interfacial stabilizers, mesoscale assemblies, advanced coatings, and autonomous devices. Alex and June are here today to give you a tour of the lab and show you the tools that we use in our research.
Hi, I'm June. I'm one of the grad students in Laura Bradley's lab. So this is our initiated chemical vapor deposition, ICVD. We use it to coat different polymer coatings on various substrates. Both monomers and initiator will be vaporized and flow into the reactor chamber. With a heated filament, free radical polymerizations happen in the system. In this solventless process, we can introduce various different polymer chemistry onto different substrates. ICVD can not only coat the solid substrates, we also use it as a tool to deliver species to liquid substrates. This offers us opportunities to process polymer materials at liquid interface, and we can also study the polymer self-assembly structures at fluid interface. We categorize polymer morphologies by both optical microscope and scanning electron microscope. Current research involves studying the wrinkled polymer films at fluid interface and ordered colloidal assemblies at liquid crystal interface.
Hi, my name is Alex McGlasson, and I am a second year in the Bradley group here at the Polymer Science and Engineering Department at UMass Amherst. So welcome to the colloid synthesis lab. This is the lab where we do a lot of our colloid synthesis as well as functionalization of the colloids that we synthesize. There's a lot of focus on various applications that we have for these colloids. I am focused on using the techniques we do to synthesize autonomous micromotors that can be used for a variety of different applications. So specifically, a lot of the work that's done in this lab is done in these two hoods. So in this hood, we do all of the functionalization of our colloids. This is our hood where we do techniques where we can tune and change the shape of our particles using techniques like solvent-assisted phase separation, or we can change the chemistry and the functionality of our particles using techniques like thioline click chemistry or acid-catalyzed hydrolysis. Over in this hood, we have our big oil bath that we use for particle synthesis. We synthesize our particles using a variety of heterogeneous polymerization techniques, but the two main ones we use in our lab are dispersion polymerization and seated emulsion polymerization, which we use to fabricate anisotropic particles, shape anisotropic particles, and Janus particles. In the rest of our lab, we have a wide variety of different equipment, standard equipment that you would expect to find in every lab. Specifically unique to our lab, we have things like the rotating stir plate, or as well as also we have a high-powered centrifuge which we can use to clean up and separate our particle solutions and wash them. So one of the characterization techniques we use all the time in the colloid synthesis side of the group is dynamic light scattering, which we use for both particle sizing as well as we can also use it to characterize the motion of the particles that we use if they have any unique active behavior or active component to their motion. So the dynamic light scattering instrument that you see here is actually a shared instrument by multiple groups in the department.
I think the best part about being a grad student here is that we have state-of-the-art instruments all in one building, and we can get trained to use all of them.
Many members of the Bradley Group take part in outreach activities like the Amherst Regional Middle School Science Day, where we have 50 8th graders come through and learn about wetting properties and emulsions. Another important outreach program is Aspire, or a student-led program in research and education. This program is totally organized by PSE grad students for high schoolers interested in learning more about polymer science and engineering. Over the course of 5 Saturdays, usually in January, we invite 40 to 50 high schoolers from around the Amherst area and as far away as Boston to come and visit the Conti Polymer Research Center and get some hands-on experience with experiments in polymer chemistry, engineering, and physics. It's a really fun day, and many of the Bradley Group members enjoy not only planning this event, but also participating and working with these high school students.
I hope you enjoyed this introduction to the HIT Materials team. If you want to learn more about the research that we do, feel free to email myself or any of the graduate students in the group. We'd be happy to talk about our research as well as what it's like to be part of the polymer science and engineering community.